Welcome to Zeiss Inspect Correlate. In this video, I'll show you how to import 2D images and prepare the data for analysis. If you want to try Zeiss Inspect Correlate, take a look at the description below. There, you'll find links to download the software, request a free trial, and download training data. All you need are images or a video recording of your test and sample. I have recordings from a tensile test in the form of images. The object features a stochastic pattern, but the import process is the same for objects featuring reference point patterns. Zeiss Inspect Correlate supports the most common file formats. For images, that includes JPEG, PNG, and TIFF, for example. For optimal results, we recommend using uncompressed TIFF or PNG files. Please note that the file names must end with a number and form an ascending index. For example, test 1, test 2, test 3, etc. Supported video formats include MP4 and AVI. For a list of all supported file formats, have a look at the access point Zeiss Inspect Correlate in the tech guide. Let's dive right in. Start Zeiss Inspect Correlate via the Zeiss Quality Suite. Now, you can simply drag and drop the images or video you want to import into the software. You can even select entire folders and import them. Select the import option Deformation Image. When you drag and drop data directly onto the start screen, the software automatically creates a new project for you and displays the data in the 3D view. Of course, you could also create a new project first and then import data via drag and drop. Alternatively, you could use File, Import, File to import data. The software automatically creates a measurement series that contains all the imported images or frames of your video. Use the timeline to navigate through them. Each image or frame of a video is equivalent to a stage on the timeline. Now, because you're using 2D measuring data, you need to define the scale of your images. When you look at the main toolbar, you'll see that Define Scale is the first step. It's necessary in order to compute displacement. To define the scale, you need to define 2 points. Use Ctrl and the left mouse button to click a point on either side of the object. In this case, I measured the width of my object. Under point distance, enter the value you measured on the object. In my case, that's 25 millimeters. Now, before you start your analysis, you may want to check the pattern quality in your images. Please note that this step is not necessary when you're working with reference point patterns. To learn how to work with reference point patterns, check out the video How to Perform a Simple Motion Analysis in Zeiss Inspect Correlate. Now, back to our stochastic pattern. To check the pattern quality, you need to create a surface component. Click Define Component in the main toolbar and select Surface Component. When you create a surface component, the software finds square subsets, which we call facets, in the acquired images. These facets are identified based on the stochastic pattern. Only add surfaces with a pattern to the surface component. Deselect any background and anything else on or around the pattern, say screws, rivets, cables, etc. If you look closely at the hole here, you can see that some facets extend past its border into the background. That could cause issues later during your analysis. To avoid that, use the selection commands in the 3D toolbar and only select areas with a stochastic pattern. Use Select Deselect Polygon in the 3D toolbar. Then use the left mouse button to define the area you want to select. Click the right mouse button to finish the selection. To refine your selection and exclude the hole in the middle here, use Select Deselect Circle. Again, use the left mouse button to draw the circle. Then press and hold the right mouse button, move the cursor over to deselect, and let it go. Now we can check the pattern quality. To do that, select Pattern Quality in the drop-down list on the bottom left. Now, if everything is green, that means the pattern quality is good. Yellow areas indicate a diminished pattern quality, and in red areas, the pattern quality is too poor to compute facets. A good pattern quality means that the stochastic pattern has a high contrast, the black and white distribution is about 50-50, the black speckles are about 3 to 5 pixels in size, and are well distributed within the facets. The facet size and distribution are determined by the parameters facet size and point distance in the dialog window. The default settings usually work well, same as the computation standard. If you're curious and want more information about the parameters in this dialog, have a look at the tech guide. If you see yellow or red areas, you would have to reapply the pattern and repeat the test and measurement. If the pattern quality is good, click Create and Close to create the surface component. So much for importing 2D image series. If you want to find out how to perform a simple strain analysis, check out the next video in this playlist. If you're more interested in motion analysis, have a look at the video Perform a Simple Motion Analysis in SeisInspect Correlate. And if you're looking for a more comprehensive training, check out the Inspect Correlate Aramis Basic e-learning. You'll find the link in the description below.